Electricity, class 10th, science, NCERT textbook questions. Page number 213. Question number 1. Question 1 says, draw a schematic diagram of circuit consisting of battery of 3 cells of 2 volt each, a 5 ohm resistor, and 8 ohm resistor, and a 12 ohm resistor, and a plug key, all connected in series. So 3 resistors are there, and there is a battery of 3 cells, and a plug key. If key is closed, then current will flow like this. And these resistances are 5 ohm, 8 ohm, and 12 ohm. Now, question number 2. Redraw the above circuit, putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across 12 ohm resistor. What would be the reading of the ammeter and voltmeter? So let's see question number 2. So same diagram, 5 ohm, then 8 ohm, then this is 12 ohm, and there is voltmeter here, and then ammeter. Here there is plus, minus, here there is plus, minus. Then battery, so here 6 volt battery. There is key which is closed. Current is flowing. Now, in this question, we have to find out what is the value of current and what is reading of voltmeter. So for this, we can calculate total resistance of the circuit, and then we can find the current. So total resistance, all 3 resistances are in series. So R series will be equal to 5 plus 8 plus 12 equal to 25 ohm. Then we can apply Ohm's law, V equal to IR. So we put the value, V is given as 6 volt, I is to be found, and resistance is 25. So which will give I equal to 6 by 25 ampere. So we have got the value of ammeter. Ammeter reads the current, so it will be 6 by 25 ampere. Or if we further simplify, we will get 0.24 ampere. Now we have to find out what is potential difference across this 12 ohm resistor. So that will be the reading of voltmeter. So that will be equal to V equal to IR. So here R will be 12 ohm and I will be 0.24 ampere, because same current will flow through all the resistances. So reading of voltmeter V will be 0.24 multiplied by 12, and that will be equal to 2.88 volt. So this is answer. Now let's go to next question. So page number 216. Question number 1. Judge the equivalent resistances. Judge the equivalent resistance when the following are connected in parallel. So 1 ohm and 10 power 6 ohm. So rule is there, if some resistances are connected in parallel, then resultant resistance will be less than the least of them. So definitely the equivalent resistance will be less than 1 ohm. So approximate value will be 1 ohm. Let's evaluate it. 1 upon Rp will be 1 upon 1 plus 1 upon 10 power 6. LCM will be 10 power 6. So here 10 power 6 plus 1 and 10 power 6. So this will be equal to 1, 2, 3, 4, 5 and 1 divided by 1, 2, 3, 4, 5, 6. So Rp will be 1, 2, 3, 4, 5, 6 divided by 1, 0, 0, 0, 0, 0, 1, which is roughly equal to 1. Second part. In second part, 1 ohm, 10 power 3 ohm and 10 power 6 ohm. The result will be almost 1 ohm. We can evaluate it 1 upon Rp, 1 upon 1 plus 1 upon 10 power 3 plus 1 upon 10 power 6. LCM will be 10 power 6. So here 10 power 6 and this will become 10 power 3 and this will become 1. 1 upon Rp. It is useless to evaluate. It will be roughly equal to 1 because we can easily evaluate like 10 power 6, 1, 2, 3, 4, 5 and 6 and then this is 1000. So 1, 0, 0, 0 and then 1. So it will be 1, 0, 0, 1, 0, 0, 1. So this will be equal to 1, 0, 0, 1, 0, 0, 1 divided by 2, 3, 4, 5, 6. Ultimately, it will be Rp equal to which is 0.99. So that is equal to 1. Now, let's take next question. Question number 2. An electric lamp of 100 ohm, a toaster of 50 ohm. So this is 100 ohm. Then a toaster of 50 ohm and a water filter of 500 ohm are connected in parallel. So they are connected in parallel to a 220 volt supply. Here 220 volt. Now, what is the resistance of an electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it? So here we have to find out what is effective resistance and then what is current. So effective resistance can be found by calculating these three in parallel. So 1 upon Rp will be equal to 1 upon 100 plus 1 upon 50 plus 1 upon 500. So let's evaluate. So it will be 500. This will be 5. This will be 10. And this will give 1. So 1 upon Rp, it will become Rp equal to 500 divided by 16. And if we evaluate it, it comes to be 31.25 ohm. So we have got equivalent resistance. Now we have to find out current. So I equal to V upon R, which gives I equal to V. We have 220 volt and resistance is 31.25. So if we simplify it, so we will get from here 2 zeros we can shift in numerator, 0 divided by 3125, then we can divide it. So answer will be 7.04 ampere. Now let's go to next question. So question number 3. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? So the first point is the current is divided through the electrical devices. The total resistance in the circuit is decreased and devices work properly. So in parallel, what happens? Total resistance in the circuit decreases. So devices work properly. And the second point is, if one of the device stops working, the working of other devices is not affected. So this is the reason why we connect the devices in parallel. Now let's go to next question. Question number 4. Question number 4 says, how can three resistors of 2 ohm, 3 ohm and 6 ohm be connected to get, first requirement is 4 ohm and the second requirement is 1 ohm. So let's take first case. So solution to case 1, we have to get 4 ohm. So what we do, we just put 2 ohm here and then 3 and 6 in parallel. 3 ohm here and 6 ohm here. Let's evaluate it. So first we evaluate this 3 and 6. So 1 upon 3 plus 1 upon 6. LCM will be 6. This is 2 and this is 1. That is 3 upon 6, which will give Rp as 2 ohm because this is 1 upon Rp. So this will give 2 ohm. So this is equivalent. So we have got this is 2 ohm and equivalent of these two we have got as 2 ohm. So total resistance will become 4 ohm. Now we have to connect these three resistances in such a way that resultant should be 1 ohm. So if we connect all three in parallel. So let's check what happens. So we are taking three resistances. One is 2, another is 3, third one is 6. Now we find out what is equivalent resistance. So 1 upon Rp will be 1 upon 2 plus 1 upon 3 plus 1 upon 6. So LCM will be 6. So this will be 3, this is 2, and this is 1. So 6 by 6, which is 1. So Rp will be 1 ohm. So we have got the answer. Now let's go to next question. Question number 5. What is the highest and the lowest resistance that can be obtained from 4, 8, 12, 24 ohms? We are given four resistances: 4 ohm, 8 ohm, 12 ohm, and 24 ohm. So we know that highest resistance can be obtained when we connect these resistances in series. So 4, 4 ohm, then 8 ohm, then 12 ohm, and then 24 ohm. So in case of series, we find total resistance, and that will be 48 ohm. Now, so this will be maximum value, R maximum. Now, to get R minimum, we find Rp. So we connect all four resistances in parallel. So 1 upon Rp will be equal to 1 upon 4 plus 1 upon 8 plus 1 upon 12 plus 1 upon 24. We take LCM. LCM will be 24. So this will be 6 plus 3 plus 2 plus 1, which is 1 upon Rp. So 9 to 11, 12. So 1 upon Rp equal to 12 by 24. That is 1 upon 2, which gives Rp equal to 2 ohm, which is minimum resistance. Thank you.